activities outside directly and quickly. As nanotechnology director for the moment here in UQAM, and as a director of what we call the Quebec Center of Advanced Material, means that I have access somewhere to more than 120 labs, and we have a big platform around Canada and around Quebec, the biggest advanced material center in Quebec, of course, and in Canada. This is why, and the North Sud International Development Research Center will be independent research institution that could be used or dedicated to international development between all living forces, especially Moroccan living forces around the world, and it will be open to international living forces too, and means Moroccan and elsewhere. And the idea is to promote and pursue applications for the chemical science, sustainable development for and economic growth, and logically all the people from the IKMES, they will get the link soon for this platform. And you are welcome to be involved and to keep pushing, because now we are in virtual science, and it's better maybe to keep it like this. And thank you so much for your invitation, and keep growing, and you deserve it. Thank you so much.
Thank you. Thank you so much, Professor Siaj, for this nice word. Now we give the words to Professor Hammouti, speaker opening ceremony.
Assalamu alaikum. Hello for everybody. I can not show the degree of my happiness and warm welcome to all the participants in this international conference. I say so welcome to all our guests and speakers from all over the world who are here to share their knowledge and experiences with us. Thank you. And this is mainly the objective of this event, which was founded in 2016. During 10 days, we are sure that we benefit from our conferences and also our students to share knowledge each together. Our conference is now well recognized by the eminent speakers, first and thereafter international institutions as Elsevier and Springer, which offer our students the opportunity to publish their selected paper from IKMES 2020. Again, I welcome all the participants from the bottom of my heart, and special thanks to all the partners. I cite our president, Professor Yassin Zaghloul, the Dean of Science Faculty, Professor Ismail Radi, Dr. BADR, Director General of IRESEN, our colleague Daoudi Mohammed from the coast Saudi, Professor ENNAOUI, AHMED, Professor Mohammed Siaj from Canada. Thanks also to our members of organizing committee, especially Professor Touzani, Professor Jafali, Professor Awinti, Professor Bouklah, Professor Essifi, and all colleagues from the university who hardly work on the realization of this opportunity. Thanks again and welcome to our virtual conference. Marhaban bikum, and very welcome.
Please, now I will give moderation to Professor ENNAOUI. If it's possible, he will take the present Professor Dr. IKKEN, and after Professor Nazardine. Please, Professor ENNAOUI, the floor is yours.
I'm here. So, do you hear me?
Yes.
Fine.
Yes.
Okay. Okay. First of all, I want to congratulate all committees from Wujda and in KAUST and in Canada for this very amazing conference with a very high level from the fundamental to the application. That's one thing. The other thing I want to say is that the actually Morocco have a lot of challenge, as you know, with COVID, with the South Morocco problem, etc. And I think we have to be much more creative and innovative in the future, especially scientists. And I think before I give the floor to Brother IKKEN to talk about the hydrogen as a vector for the economy, not just for the energy, but for the economy, I want to say some word about him because as a president of the scientific committee and as I know him since 2011 when I met him in Germany, I know a lot about him in terms of struggling in Morocco and to bring this IRESEN to a very high level. I think IRESEN now is became because, of course, a lot of people are working there, but the driving force is the executive director, Badr IKKEN, and also how he was able to motivate a lot of people, even politics, to make things working. So when I met Badr IKKEN in 2011 in Germany, he asked me to come to help him in the scientific committee. At the time, I didn't know what's mean this because I don't have a good experience or in Morocco in the past, and therefore I was very skeptic. But when I come there and I find that there is a magic way to do things, and I think I want to congratulate Badr IKKEN because he was able really to motivate a lot of people and to make things running. Now IRESEN is a very big institute. And by the way, my colleague from Canada, he talked about the virtual way to do things. I think, I believe that IRESEN will be a very good component for this virtual initiative in the future. I'm sure they will bring a lot. So, Dr. Diploma Engineer Data Badr IKKEN, I want to thank you for participating, and the floor is yours to talk about hydrogen in Morocco for the future.
Thank you very much, dear friend, Professor Ahmed ENNAOUI. Thank you for the kind words, and I have to say that I had the real pleasure and an honor to cooperate with you, to have the opportunity to work on a lot of topics and challenges. I will have the opportunity in a few slides to mention as well the current activities and then the future activities. But again, thank you very much for your sustainable support and kind support. I hope you are able to see my screen and my presentation. Ahmed, are you able to see my presentation?
Yes, yes, yes. I don't know if it's a full screen, but I see, I saw it. Yes.
I'm now in the first slide.
Now the second one.
Yeah, perfect.
Go ahead, Badr, it's good.
Okay, thank you. If you allow me, I would like then to say, if I have to introduce IRESEN, what we would like then to do, and this is an equation of Africa's future. This is an equation which I saw one time when I was visiting MIT, and one professor spoke about then the future of Africa and the dependency of the economic growth on climate change, population growth, and technology adoption. And we are trying at IRESEN to have an impact and to be able then to develop this part, the technology adoption. Today, IRESEN has two missions. We are a funding agency, and we are funding collaborative R&D projects. And I have to say that at the beginning, we were more funding R&D projects in technology readiness levels between 4 and 5, and slowly we're trying then to add other funding programs to be able to finance projects on a TRL's technology readiness levels between 5 and 7. And I will mention one current program which we launched now in this difficult time of the pandemic COVID-19. This is on the one hand. On the other hand, we are developing R&D infrastructures, and from the beginning, the idea was not to be a competitor and then to do competition against universities. No, from the beginning it was clear we have to build a bridge between the universities and the industries and companies. And this is why we started to build such kind of living labs, applied research infrastructures, and to introduce, I will show you then a few pictures before starting then my presentation, because if we have to speak about hydrogen, if we have to speak about the framework, it's important then to speak about one of the common possibilities and technologies to produce green hydrogen and green derivatives of hydrogen using green electricity coming from solar energy or wind power. Our first R&D platform is the Green Energy Park, and this R&D platform is dedicated for solar energy technologies, different technologies, photovoltaics, thermal solar energy, and other applications. The second platform, which is already, the first phases is already then finished. This is the Green and Smart Building Park dedicated for green buildings, energy efficiency, smart grids, and sustainable mobility. We are now in the phases to prepare the next platforms. The next one is in Morocco, is the Green H2A, Green Hydrogen and Applications, and we will start the construction of the platform next year, and I will give you more details about the activities and the R&D platform in the next slides. We're planning as well to have one R&D platform dedicated for biogas, biomass, the agro-energetic, and the platform for the Nexus Water Energy. And I have as well to mention and then to highlight one of the, for us, very important projects, and we are very proud to have developed one R&D platform in the Ivory Coast called the Green Energy Park Morocco Ivory Coast, and we finished already then the construction of the platform. And this is very important if we have to try to develop more and more this continental cooperation. It's important to start as well with joint R&D infrastructures, and we developed the Green Energy Park Morocco Ivory Coast with one well-known institution in the Ivory Coast, l'Institut National Polytechnique Houphouët-Boigny in Yamoussoukro. This is a picture of the Green Energy Park, and I hope we will have the opportunity one time to organize as well the IKMES in Ben Guerir, and then to have the opportunity to visit all the facilities and then the labs. This is the second platform, the Green and Smart Building Park, and this is near to the Green Energy Park. And This is the first part. This is the part regarding the R&D infrastructures. And on the other hand, the funding and then financing of applied projects, we have two ways. We have then the technology push through the funding of the TRLs, which I mentioned, 4 or 5, and then we have as well the market pull and the support of the market. And this is why, if you allow me maybe then to tell you that we have now one call ongoing, the Green Inno Boost, and the idea is really then to help companies, to help researchers who have a concept, who have already then first results, to help them to go and then to move from the innovation to the market, or from the research to the innovation. And now I would like then to share with you some insights about the current situation and why more and more we're speaking about Power to X, about the application of green hydrogen. And maybe I would like then to start with this slide. This is a well-known, and I will say then an old slide. My dear friend, Professor AHMED will remember, of course, this slide. I took this slide from a presentation of the Desert Tech Initiative. It means more than 10 years, we had already this vision, and a lot of people and researchers had already then the vision to produce clean energy in some regions of the world in which we have an important potential. This is in this case the MENA region, and then you see there are very important irradiation regarding solar energy, and as well as the wind speed. We have a very high as well wind speed in a lot of parts of this region, and it means we might be able, and then we would be then able to cover our need and as well to be able to export this energy. But at that time, the problem was, if we had to export this energy through the green electricity, we had to use then the electrical grid. And this was then the problem regarding all the interconnections. And if we have then to sell one electron from Morocco, for example, to Germany, we have then to go through different countries, and then we had a lot of challenges. This would be a day possible, but the opportunity regarding then the production of green hydrogen, to use the renewable energy to produce green molecules and then to export the green molecules. And what is now the Moroccan potential? Of course, I started already with the renewable energy potential, and it's important to mention that we have a technical potential regarding solar energy of around about 50,000 terawatt hour. It means if we have to install a lot of power plants, we might have an installed capacity of 20,000 gigawatts. And this is a lot. This is regarding then solar energy and PV. If we have to take the example of wind, only then wind onshore, we have a technical potential of more roundabout than 11,000 terawatt hour. If we have as well to install wind power plants, we might have 6,000 gigawatts. If we see this potential, and if we have to use only 5% of the technical potential of the solar energy and wind energy, we might have more than 1,000 gigawatts. Today, we are consuming, and our need in Morocco is approximately 10 gigawatts. It means clearly when we reach as well 2030, if we have 25 or 30 gigawatts, we are clearly able to cover our need and then to export a lot of energy. We have as well the successful experience and then successful deployment of big solar energy power plants and wind power plants. We have now the political support clearly we have the vision of His Majesty then the King, and we still have all the time a very ambitious strategy. There is a strong international partnership, and we were glad to sign a few months ago with Germany, a very important country in the European parts of the in Europe, to sign an agreement and then to have a collaboration regarding green hydrogen. And there we have as well then a lot of connections between Moroccan industries and European industries, as well as German, especially German industries. We have, and this is why I started with some pictures, and then please, maybe then of course I had to highlight maybe then more the numbers of the publications and papers which a lot of researchers and students are doing in these topics. But I wanted then to show on a very quick way to show some pictures, but it's clear now we have more and more researchers and experts in the topic of renewable energy, and we have as well more and more R&D infrastructures. And I am only then speaking now about the Morocco. If we have to have the access, and we are very glad to see that there are a lot of experts and professors from the Moroccan diaspora helping as well the colleagues, and then with a strong commitment to support then the science and technology in Morocco. We have then a real, I will say, scientific power in Morocco. Last but not least, the connectivity with a lot of countries as well as with the European Union. And as I said before, if we have to start to develop, as Professor AHMED said, this green hydrogen economy, we are not obliged to go only then through the electrical grid and then to be limited, but we have a lot of opportunities, a lot of possibilities. We're able then to use the maritime transport, we're able then to use as well existing pipelines, and they of course as well the electrical grid. Those are some examples, and I have to say that this depends on the year of the tenders, and regarding then Morocco, those are then old prices regarding the solar energy. Regarding wind, we reached then a real record, because we are then below than the 3 euro cent per kilowatt hour. But as well now there are tenders in preparation for PV photovoltaics, in which we're as well below the 3 euro cent per kilowatt hour. But we have already, we saw in some other regions worldwide that we are already then below this magic limit of 2 euro cent per kilowatt hour. And this is important, and I will mention this because if we have to be competitive with hydrogen produced by fossil fuels and other derivatives, normally we have to be then below the 2 euro cent per kilowatt hour to reach a cost of $2.3 cent per kilowatt hour for a kilogram of hydrogen. What are we doing in Morocco? And I'm very glad then to be a member of the National Commission for Hydrogen and Power to X. We started in 2018, and we cooperated with other partners. This is a slide, a figure from the study from the World Energy Council. And you see that Morocco was identified as one of the 6 more important and as they said, very front-runner countries regarding power to X and regarding the export of green hydrogen. 2011, one of the remarks was to say there is maybe then more need to have more political then support, but I think then in this last 2 years we worked a lot in this regard, and a lot of studies confirmed then this important position of Morocco. And what does it mean? It means that we, for the mid and long term, it's clear to say we're not speaking about an economy for tomorrow. We are speaking about then an important economy and green hydrogen economy for the day after tomorrow. We are speaking about then 2030 to 2035, and different studies, and I will then tell you then more about then the studies which we conducted with partners, showed that we would be able to cap up to 4, and then for the long term up to 8% of the global power to X market. And this will mean a huge business. This would mean a very important budget. If we have to see, we're speaking about then an opportunity of more than 100 billion of euros. We started in 2011 with specific studies for Morocco. The first one was a market and technology study. We conducted this study with Fraunhofer Institutes, and the lead was conducted by IMWS. And the idea was really to analyze the maturity of the different technologies, and then to see if we have then to start, if we have to speak about the midterm, and then as well as then the long term, what are then the technologies, and how is then the maturity as well of the markets. The second study was conducted with Fraunhofer ISI, and this was to identify the opportunities and the potential in Morocco. And then we did a kind as well of a technical economic assessment, as well as a social economic assessment. And the third study was in partnership with different R&D institutions, but as well with specialized economic, how do we say then, experts in this field to prepare the setup of a Moroccan strategy and then roadmap. And we are now in the last step and stages. And I hope that in a few weeks, our minister will inform, and then will present this ambitious strategy. And last year, our minister, energy minister, Mr. Al-Bah, set up a national commission for power to X. And I mentioned already the alliance between Morocco and Germany. And if I have to give you then a few information or a few insights about then the potential and the opportunities of the power to X market for Morocco. For the short term, it will start with green hydrogen as a feedstock for the industry, and especially for the fertilizer industry. You know, in Morocco, we have a very well-developed fertilizer industry, and we are one of the most important phosphate exporter worldwide, and we are importing every year 2 million tons of ammonia. We might have the opportunity to cover a part of our need at the beginning, and then later on maybe then to cover all the needs, existing need regarding then ammonia, and to be able to decarbonize then a part of this important then industry. Later on as well, there is a need regarding the methanol. Regarding the mobility, this will come in Morocco maybe a bit later. Why a bit later? Because of course, we don't need only then to install, to have then a pumping station for and filling stations then for hydrogen, but we have as well then to change all the existing infrastructures as well regarding the heavy trucks and then vehicles. This will take time. But regarding the export, if I have then to come back to the short term, there is an opportunity as well to start and then to export liquid fuels and synthetic, for example, diesel and synthetic kerosenes, because our neighbors in Europe, they are now planning by 2030 to have a percentage of synthetic fuels, synthetic then kerosene, for example, to have then the adapted regulation. And this is why there is an opportunity for the export. This current model and the strategy will show that we would be then able, regarding this market and this sector of power to X, to have maybe 1/3 for the domestic need and 2/3 for the export. And this is clearly a huge opportunity for our country, because in the past, when we spoke about then this paradoxum between 20,000 gigawatts of a potential of solar energy and the need of 10 gigawatts. And if we have to say we have then more potential and the opportunities as we are able then to consume. And this is why then the export will open a real opportunity. And this might become in a few years like the automotive industry or car industry were able to produce in our country, and we have a lot of added value, and then to export the green molecules in different form. Yeah, this is to show you, this is the classical model in the past. We had some industries to produce an electricity and then to go to the consumers through the electric grid. But now we might have the opportunity using then the renewable energy and the mix of renewable energy to produce then clean electricity through electrolyzers. And we hope in the future, and I will mention this and speak about this when I speak about then R&D, there are a lot of future technologies, and then to be able then to store as well this then hydrogen and then to use it in different industries. And we have as well the possibility then to use it as I said before, as a feedstock or as an energy vector. And then later on, we have as well the transformation industry. We are able then to transform this green hydrogen and to produce different derivatives. And we have as well the opportunity to do as well something important regarding the circular economy, to cut CO2 and then to take the carbon and then to produce other synthetic fuels. And this is then the objective. This is another example. Of course, we have now, and I will then mention about then the current situation. We have now in Morocco smaller electrolyzers and using the renewable energy, and the idea is to move to higher capacities as well as slowly to move from the megawatt to the gigawatt. This would be then the challenge. But this is a model in two sites in Morocco, one on the north and one in the south. And when you see then the levelized cost of hydrogen, we see that this is possible to cover up to 90% of the clean electricity, to be able only to use renewable energy, a mix between wind and PV, to be able then to produce green hydrogen. And as well regarding the cost, we are able to reach then this magic limit of 2.3 euro cent per kilogram of hydrogen. This means that we are not speaking, this is not today science fiction, but because of the decrease of the cost of the renewable energy, because, and this is the advantage, clear advantage in Morocco, we have then in some sites a very high load factor regarding wind power, as well as an important irradiation. And it means in some parts of the country, we're able then to have right mix, to have a load factor of up to 60–70% of wind power, as well as solar energy. And we're able then to reach 85 or 90% using only then renewable energy. And those are projections. Of course, this is based on some models. We would be then able by 2030 there is a worst case, best case, to have up to 10 gigawatts regarding then the reference case, and up to maybe then 20. But it's important to say that by 2040 we might then go beyond than 30 gigawatts, and by 2050 then more than 60 or 100 gigawatts. It means clearly the potential is huge. What are we then doing? What do we have then to do? Because I have then to mention, and I have then to share with you, and then to tell you, even when we tried to develop the capacity building and the expertise and the know-how in Morocco, we did it. And I said before, we have today a lot of experts, but it was not the case 10 and 15 years ago. We had a lot of people sometimes working more on basic research, and we didn't have the people working on the different levels of the TRLs to be able then to valorize all the results. My friend, Professor AHMED, when he spoke about then this first meeting, and when I had the meeting with him, and we spoke about what we would like to build and to set up in Morocco, and when we had this discussion with a lot of passion, because it's important, and I felt as well that there is a real passion from his side, and I would like as well to thank him for the support and for the commitment, and maybe it was the same, he felt as well then that there is a passion to develop and or to contribute to the development of our country, as a lot of people today participating in this conference are doing. When I started to discuss with him 2011, we didn't have any facilities. We had only then in a few labs some equipments distributed in different labs in our kingdom. But slowly, the idea was really then to build more facilities and then to have really a task force. Today, we have an advantage, because when we started 2011 with the Moroccan Solar Plan, we had to start, and we started with commercial, to prepare commercial projects, even if we didn't were then ready to be able to help as well companies and industries. And this is why it's important to start today very early, and I would like now to focus more on the green H2A. What are now the current situation in Morocco? We have in some universities, and we have as well now a small electrolyzer. There are works regarding membranes, regarding the impact of the intermittency of renewable energy, a lot of modelization as well. This is the current range. And we are now starting, when I spoke about the green hydrogen and application platform, to prepare a platform with different pilots with a range of 5 megawatts. And this is why I said more technology readiness level of 5 up to 6. And on the same time, we are now, and we are very happy to have this strong collaboration with industrial partners like OCP, and as well with R&D partners like Fraunhofer in Germany, but as well through the support of the German cooperation, we have, and we had some negotiations by the beginning of this week, yesterday and the day before, with the German partners, and there is a commitment to fund up to 75 millions of euros for this topic for Morocco for the next 4 or 5 years. And this is very amazing and important. And the idea is as well to prepare one reference project, to have a project with a capacity of 100 megawatts. But we, from the IRESEN side, we will more focus on the part in the middle. And this is why, of course, we are very interested to cooperate with all the different partners, researchers, universities. The idea, of course, when we build then the green H2A, the platform, and we build as well in the past the platforms, they are platforms for open, for all the partners, and those are then international platforms and continental platforms. What are the planned pilot projects in the green hydrogen and application? We have, of course, one multi-technology electrolyzer pilot platform. We will have then different electrolyzers with alkaline, PEM, as well as high temperature. We launch already then the tender, and normally we will, in the next weeks, we will select the partner consortia, which will build then this first multi-technology electrolyzer platform. This is then the first one. And the second one is the power to liquid then platform. We will have then Haber-Bosch, Fischer-Tropsch to be able to produce then green ammonia, to produce as well green methanol, and as I said before, synthetic diesel and synthetic kerosene. Of course, those are bigger pilot projects, of course, than for applied R&D, but we will have in the green hydrogen application platform as well conventional labs dedicated for different topics. And this is why I said before, there is a huge opportunity, because when we speak, and then Professor AHMED, when he said, this is not only, we are not only speaking about then green hydrogen, we're speaking really about the green hydrogen economy, a real new economy, because there are a lot of parts of the value chain, and we will have different labs dedicated for a combustion lab, a hydrogen mobility lab, as well as a water splitting lab, and then different other parts of the value chain. And we would be then very happy. And when I heard that Professor Mohammed Siaj said then in Canada, the idea is to build really then a virtual network. I hope we would be as well able to collaborate and then to work on this topic. We're now working on a kind of R&D and industrial cluster, and then we would like to have it on a regional level, because we saw in the past, and we had some experiences, we saw this in Europe as well as we in North Africa, even if we developed important and ambitious power plants regarding the industry integration for solar energy, it was not a success. And then we saw we had then a lot of companies stopping then the production in Europe and going then bankruptcy. And we have now a lot of value chain more than in Asia. Of course, this is good, but we saw during then the pandemic COVID-19, it's important to have the adapted supply chain, and then to have as well the possibility to guarantee this supply chain. And this is why I think it's important to develop local industrial clusters. And if we have to develop then a local industrial clusters, we need a lot of expertise, and we need this cooperation between the universities, between the research centers and the companies. And this is what we would like then to build with the partners, with Germany, with France, with Spain, and of course we're very then open to see how we might then use now this instruments which a few years ago we didn't use every day softwares to be able to meet virtually, to cooperate then virtually. This might help us. And the topics would be, of course, then the hybridization of renewable energy. This is very important. The production of the hydrogen, the different technologies, and we have the technologies which are today mature and which are very old technologies, but there are as well very potential and promising technologies for the future. If we have to speak, for example, about water splitting, maybe then Professor ENNAOUI will say a few words about then this technology. We have then the transport and the storage, and there are a lot of opportunities. We will have a project next year to store then to store hydrogen in all then mining, salt mining sites. And then, of course, there are a lot of other challenges. Green chemistry, we have the transformation industry. Then later on, we have to capture carbon, to store carbon, and then to use it for different applications. And then the hydrogen mobility industry applications, there are a lot of applications. And this, we would like then to set up then a framework to be able then to cooperate. And we're very happy and glad because as well on the international level. We have a very good collaboration with international organizations like ARENA, and there is a collaborative framework, and we're very glad together, Morocco with the European Commission, to be the facilitator of this for the next 2 years of the green hydrogen framework and collaboration framework. Yeah, this is the topic about then the green hydrogen economy for a real potential for our country. But of course, then we need a lot of research. We need to be able then to support our companies, and we need to prepare ourselves to be then able, when we start with the commercial projects, and to be able then to help them and then to play a role. And then on the regional level, this is a real opportunity, because this might open, and this will open a real opportunity to develop a new kind of then partnerships, a kind of clean energy Union Europe-Africa partnership. And this will allow us then to develop jointly infrastructures. Now today it's difficult then to transport then hydrogen, or to transport a lot of high quantities of hydrogen. But we might be then able, and we have to transform this hydrogen and then to use a lot of ways to export then this energy. And this is an opportunity for us to develop industrial transformation industries in our country, and then to develop very important models jointly through the knowledge transfer, capacity building, to have maybe the joint infrastructures, and to develop then a new kind of clean energy economy. This is then the dream, and I hope we would be then able to do this, and we would be then able to do this only if we have then real support from our researchers, as well as said at the beginning, from our as well Moroccan diaspora, to be able to be ready in a few years, and then to prepare all the infrastructures, and to prepare as well then our the basis to be able to play an important role in this green hydrogen economy. Of course, what we would like them to do, I think Professor Daoudi said at the beginning, the idea, of course, is to decarbonize our economies, and we would like them to participate and to contribute and to provide a clean part of the clean energy to our planets. Thank you very much for your kind attention. I would like then to finish my presentation with this information. We would be very happy, and of course we will have then a very full week with a lot of very interesting presentations in different topics, but we would be then glad to invite you to attend the first World Power to X Summit. Normally it has to be then in Marrakesh, but it would be as well then a virtual one. It means the international one, and we would be very glad to see you participating. This is a warm invitation to all speakers, participants to attend the World PTX Summit, and thank you very much for your kind attention.
Okay, thank you very much, Si Badr. First of all, I want to ask you, are you going to stay until the end of the next session?
Yes, I will.
Okay, then I propose that all questions will be removed to the end, because the subject is so important, and if we put it in between the two sessions, it will be very short. Therefore, I propose that the attendee can prepare their questions about this topic. There are a lot of bottlenecks in this subject, which are really the subject of this conference, because there are a lot of manpower, student, graduate student, professor working on catalysis, on electrochemistry, and on material science. And all these backgrounds are very important to develop the green hydrogen, either to use just the solar panel or wind to power electrolyzers. And even this, you need catalyzers, and you need a lot of research, fundamental research on catalytic electrodes in order to avoid the over potential in the electrode. And this is very important. So we will discuss this afterward. And also, if we talk about artificial photosynthesis, for example, learning from the nature, this is also a very important in this topic. So I propose to go, I want to thank you first for this very important subject. As I told you, it's not just green hydrogen, it's hydrogen economy. Morocco can be the next sorry cost. It can be the next Saudi Arabia in the future. Instead of fuel of petrol, we will have hydrogen in Morocco and to sell it everywhere in the world. So I want to ask my colleague Nasruddin. I want first to thank him before. Nasruddin is I think I even don't need to introduce him because he's very well known all the world. His work first with Professor Gretzel in the beginning on dye synthesization solar cell was a huge work. Now the perovskite is coming, which is maybe working in the same way than the dye synthesization, and he's now the #1 in terms of publication, in terms of patent, and so on. And he has a huge group in Switzerland. I want to first to thank him for coming. I think his each index, if you just scan his summary and his bio in the web page of this conference, you will know that we are talking about somebody very, very important. So we are very happy. I want to thank you that you accept the invitation. When I send you an email, you immediately answer. I want to thank you so much. And I want to give you the virtual floor to talk about perovskite. And the title exactly is Perovskite Solar Cell, a New Paradigm in the New Energy Sector. Please, the virtual floor is yours.
Thank you, Professor ENNAOUI, for this very kind introduction. First of all, can you hear me?
Yes, we can.
Okay. First of all, I would like to thank all the Moroccans for their Independence Day and all the organizing committee members who has put together such a nice workshop, online meeting. I'm really pleased to join this meeting, and thank you, ENNAOUI, for inviting me. So let me share my screen. Can you see my screen? Yes.
Not yet.
We can see the screen, but not the presentation.
So how do I do that? So you are presenting. So yes, I go here, start presentation. Yes, entire screen and share. Cannot see my screen, isn't it?
No, not yet. Not yet.
You are presenting to everyone. Start presentation. So it says yes. Well, can you use my presentation which I have sent to you otherwise, if possible? Can you see that one? Hello?
AHMED micro.
Can you see the screen again?
No, we don't see it.
No.
No, not yet. Not yet.
your entire screen. Share. Now?
So just wait 1 second. That's not it. Maybe it's too heavy. Now it's okay. It's fine. Go ahead.
Okay, I'm glad. Well, finally it's working. Well, let me present. So my topic, the perovskite solar cells, a new paradigm in the energy sector. And this topic is really well aligned with our previous presentation, hydrogen economy. And if we have a cheap electricity produced using these cheap materials, which are the perovskite materials, which you will see in my presentation, I think we can generate electricity at negligible cost. So before I start, let me just I'm working at EPFL. Here is my email address. So let me just use the pointer. So this is my email address. You can contact me at any time regarding this presentation. So I'm also working visiting professor at King Abdulaziz University and Korea University as a world-class professor. So this is our campus. So it's a very nice campus next to the lake. I come back to the topic, the perovskite solar cells. Today, 25.5% efficiency has been certified at Newport. How does this compares with the silicon solar cells? If you look at the silicon solar cells, which has a 26.1% certified efficiency. So the perovskite solar cells and silicon solar cells very close, in fact. However, if you look at the processing conditions for silicon solar cells, they're extremely hot and high temperature and several steps involved with very clean room facilities. Compared with the perovskite solar cells, you have a solution processed material which self-forms a three-dimensional material encapsulated between the hole transporting material and electron transport material. This gives you a 25.5% efficiency. However, there are minor issues, which are some stability issues and other toxicity issues, which I will discuss as we go in the presentation. So what is perovskite material? And perovskites are ABX3 type of family. A is a organic or inorganic cation, as shown here, cesium, methylammonium, formidinium, and B is a metallic.
Maybe you have to go to the next, because we see always the first slide.
No?
Not yet. There is some.
Yeah, but maybe the file is too big. I cannot. So can you see the third slide?
No, only the first title. Oh. The title, we see always the title.
Okay, so we have issues there.
There are many ways to run the slide. Maybe you have to choose which one is working properly.
So there are many ways to run.
Now we see the next one. Yeah.
Okay, so now you see the comparison between silicon solar cells and perovskite solar cells.
Yes, exactly.
Okay, fine. So I just repeat one sentence, that perovskite solar cell efficiencies are 25.5. These are the certified at stage Newport, and silicon solar cells are 26.1. But the difference in the fabrication method is huge. Here, silicon solar cells requires high temperature, perovskite solar cells requires 120 degrees temperature. Can you see the next slide? Metal halide perovskites offer advantages as a solar light harvesters. Can you see this slide? Hello?
Yes, it's fine. It's fine.
Okay. Yeah. So what is perovskite materials? So perovskite materials can be classified as a ABX3. A is a simple inorganic or organic cations, as shown here, cesium, methylammonium. The B is a metallic cation, 2+, lead, tin, and other type of cations. And X is a halide. Combination of these three metal elements gives you very beautiful properties, as highlighted here. The three strong properties: absorption in the whole visible region, you will see in the next slide. Tunable band gap, you can change its properties, absorption spectral properties, by changing the cation and anion. And the excitation dissociation energy extremely small. So these three properties together makes this material, wonderful material, to generate electricity close to the silicon solar cells. And if you see,
you should go to the next slide.
Yes, I went to the next slide. Can you see that one? It's
No. Yes.
Okay.
Now we see the
absorption spectra. So methylamine is So if you look at this materials absorption spectra, it starts around 380 nanometers and absorbs all the way up to 820 nanometers. And it has a beautiful emission properties, and these emission properties we can make use of for both applications, where you shine the light and you extract the charges. This works as a solar cell model, and you inject the carriers, electrons and positive charges, and it gives you the luminescence properties. So that way, these materials are having a dual application, solar cell applications as well as light emitting applications. There is a huge research going on these two areas. And if you look at another interesting property, the onset of this perovskite material is very sharp. And if you see the red panel, where I'm comparing the three materials, the perovskite onset and then the gallium arsenide onset, which are similar, where onset is steep, compared to silicon solar cells, the onset is a very sluggish. So this onset, steep onset property gives you the material property. The microstructure of this material has a very low trap densities, and the low trap densities is the result of a self-assembly of these 3D materials, and that allows you to extract carriers at the interface. Can you see this next slide? This is the slide where you can prepare the perovskite solar cells. The scheme.
Yes, it's fine.
Okay. So now we have the scheme which I'm showing compared to silicon solar cells. Here what we are having is, we take a conducting glass and we just deposit a blocking TiO2 layer. This is one type of TiO2 layer, followed by the second TiO2 layer, that's called mesoporous layer. We sinter it, then we deposit perovskite at 120 degrees temperature. Then we deposit whole transporting material, contact, and that gives you the perovskite solar cells. The cross-sectional image is shown here, which represents the previous description. You have a titanium dioxide as an electron transport material. You have a perovskite as absorber material, spirometers as a whole transporting material, gold as a contact. And this type of cells in the laboratory, we get 22% efficiency, which is we also certified at Newport. Now, very recently, last week, 9th November, we sent again our cells to Newport, and fortunately, we got 23.5 plus or minus 0.75. This efficiency is certified, and this we will be putting very soon a startup in Valley using this technology. So what type of modules? Can you see the modules here?
No. Yes.
Yeah. So this module is a very small mini module, 6.5 by 7 centimeters. And this type of mini modules we can prepare in the lab using spin coating system. And this gives you around 17.3% efficiency. So since the materials are low cost and the processability is a solution processing, it's extremely cheap. So this can generate a huge potential for grid-free supply of electricity. Now, that's my just introduction. So what you are going to listen from can you see the next slide? That's a outline. So what I want to show in this, my presentation is the difficulties in perovskite solar cell. That's a stability. How do we increase the stability of these materials? By 3 methods. One, we want to interface engineering so that the materials can be very stable, the long-term stability. Compositional engineering of perovskite layers. The initial composition was methyl ammonium lead iodide. As such, methyl ammonium lead iodide is not very stable material. So here we are trying to modify this composition by changing the cation, by changing the halide, at the same time incorporate additives like ionic liquids that protects these perovskite grains. So that's what you will see in my presentation if the time permits. And then we have 2 transport layers, one electron transport layer. So what we want to see is how this electron transport layer is influencing the stability of the perovskite. This interface is very important. So we are trying to improve this interface by changing different different oxide layers. At the same time,
you have to go to the next, I guess. No?
Yes, I will. Can you see the two hybrid perovskite, two-dimensional hybrid perovskites?
No, no.
Right?
We're still in the outline.
Now?
We just see the outline. Yes. Now, yes. We see the hybrid.
Yes.
So now you go back now. You go back again.
Yes. Here is the outline. So the third point is development of charge transporting materials. So this one, you will see a couple of slides on the electron transport layers and hole transport materials. So the reason why I put this one is if the students are listening, that motivates them, that gives the creative thinking, what type of materials they should really think for further developing the solar cells. So let me just go to the next slide. And this is the next slide.
Not yet. Yes.
Okay.
Yes.
So now if you look at this on the left side, ABX3 structure, where we are having a cation, and this cation size fits into this cavity. So this is a typical size, which is called Goldsmith tolerance factor. And within this Goldsmith tolerance factor, cation fits into this matrix. When the cation fits into this matrix, the perovskite forms a three-dimensional network. So this is the one which we are looking. And if you look at this three-dimensional network, on the bottom right side, you see the absorption spectral properties. It goes up to 820 nanometers. However, if we change this cation to a bigger cation shown on this table, NBA, that's a butyl ammonium, isobutyl ammonium, phenylethyl ammonium, all these type of cations or naphthalamine, these are the bigger cations. When we insert these bigger cations, now we disturb this three-dimensional perovskite into a layered perovskite. Depending on the ratio between a smaller cation and bigger cation, you can have a N equals to 1, N equals to 2 layers, N equals to 3 layers. The maximum we synthesized was N equals to 6. So now you have a beautiful opportunity to control the perovskite material itself with a number of layers. And why we are doing? Because when you disturb this three-dimensional perovskite structure, and the stability is extremely enhanced. In other words, if you take pure two-dimensional perovskite, this is extremely stable. Three-dimensional perovskite, extremely less stable. So now by combining these two aspects, we want to enhance the stability. That's what we want to do. So the next slide, that's a characterization aspect.
So yes, okay.
So in this slide, what I'm showing is a typical characterization aspect of these materials. So let me just brief you what we are doing. So we have an electron transport layer, we have a perovskite layer deposited on the top of ETL, and now we deposited the two-dimensional perovskite on the top. How do we know that we are having a two-dimensional perovskite? Take the XRD spectra of pure two-dimensional perovskite, that's a green line, and this particular peak around 5 is a fingerprint for the two-dimensional perovskite. On the bottom, we have a 11.5. This is a characteristic peak for the perovskite, three-dimensional perovskite. Now, when we deposit three-dimensional perovskite and deposit on the top two-dimensional perovskite, now you can see the red line, which has a characteristic peak of the two-dimensional perovskite, at the same time characteristic peak of the three-dimensional perovskite. And accordingly, you can see the absorption spectral properties that reflects. Now, if you go to the luminescence properties, now, if you excite your solar cell having two-dimensional perovskite on the top at 450 nanometers excitation, you can see only the two-dimensional perovskite got excited and it's giving emission. And here are the two examples which you have taken. One is a reference sample, that's a black line. It has a no two-dimensional perovskite on the top of three-dimensional perovskite. And the red one is the three-dimensional perovskite followed by deposition of the two-dimensional perovskite. If we excite from the top, so what we excite is only the two-dimensional perovskite as evidenced by the emission maxima, which is coming around 520 nanometers. However, same two samples, that's a reference, as well as two-dimensional perovskite deposited on the top of perovskite, if you excite from the bottom at the same wavelength, you see the emission is overlapping. That means the penetrating depth of your excitation laser is hampered by the three-dimensional perovskite. It clearly demonstrates the presence of two-dimensional perovskite on the top of three-dimensional perovskite. Now I move to the next slide, where you see the efficiency.
Not yet. Not yet. Try again, please.
Yeah, I did.
No. We're still by photoluminescence here.
Yeah. I did.
Maybe you have to turn off the camera. You don't have to show yourself because it takes too much signal. Turn off the camera, Nasruddin.
Yes, that's what I'm doing. So let me do that one.
Yeah, and try, please. Thank you.
Yeah, it's a good suggestion.
Now it's fine, yeah? So go to the next, please.
Can you see that one?
Now we see the dark. It's there are some problems. Now it's fine.
It's okay.
We see the 20%.
Yes.
75%. Yeah.
That's correct. This is the slide which I want to show. So, while using the UPS measurement data, the middle panel, that's the energy level diagram, we extracted. So the take-home message from this slide is the energy level of three-dimensional perovskite, which is here the mixed cation, mixed halide perovskite, and the energy level of the two-dimensional perovskite, that's the yellow line. So if you look at the HOMO level of the three-dimensional perovskite and then the two-dimensional perovskite, they are well aligned. However, if you look at the LUMO level of the perovskite, that's a three-dimensional perovskite, two-dimensional perovskite, which is extremely higher, similar to the whole transporting material. So what happens when you shine the light to the perovskite? So you create charges within this perovskite. The electrons, they turn around. They will not be able to go tunnel towards the whole transporting materials, going towards and extracting in towards the ETL layer. Whereas positive charges from the three-dimensional perovskite, they tunnel through the two-dimensional perovskite through the whole transporting material. So how do we know that this is happening? Let's take the PV data. On the left side, if you look at the reference sample, the VOC is 1.09 volts. After depositing this two-dimensional perovskite, the VOC has increased from 1.09 to 1.14. So the efficiency is 18.65 to 20.08. And the final optimized efficiency is 20.75. So what this shows you is that the creation of this interface layer is reducing the recombination at this interface, that is increasing your VOC. Well, the net effect of this creation of, can you see the slide, which is the stability data?
Yes.
Okay, so the influence of this two-dimensional perovskite is shown here. The black lines, the filled one is under atmosphere conditions. The stability is decreasing significantly. This is without any two-dimensional perovskite. And if you look at the black open circles, these are the under nitrogen atmosphere conditions, but still the efficiency is decreasing. Nevertheless, the moment we deposit two-dimensional perovskite on top of three-dimensional perovskite, the solid line is under atmosphere conditions, and then the empty squares are under nitrogen conditions. The stability is significantly enhanced. So our idea of stabilizing these perovskite materials by incorporating two-dimensional perovskite is a really successful strategy. So now, can we just change phenylethylamine, that's a two-dimensional cation, to a new cations? Can you see the slide here with the left side IV characteristics, molecular design?
Not yet. We're still on the same slide.
We don't move?
No, it doesn't move. Doesn't move. we see the Venn diagram. Yes.
Yeah. Okay. Okay. So this is the slide which I actually. So we discussed this slide, and I just want to discuss this slide.
Now there is a problem.
Uh-huh.
Now you have to go now to. Maybe you have to go back, I guess. This is the statistic. Then next one has to be the Venn diagram.
Can you see the Venn diagram?
No, this is the statistic. No, it's fine.
Can you see this molecular design of stability correlations?
We see the bending induced passivation. The publication.
Yes, this one, the band bending induced passivation.
Yes, exactly.
Okay. Well, let me just discuss this one. So what we are trying to do is the perovskite material as intrinsic material, and it does have some surface traps. So we are passivating these surface traps, and by doing this passivation method, what we are creating is a NP type of structure, where this is intrinsic, the bulk. On the surface, we are having a P type of material. And this P type of material is only to the extent of 30 nanometers that you will see from the data. Can you still see the slide? That's a energy and environmental science paper.
Yes, still we see it. Yes, still we see it. Yes, I'm sorry. Yes, go ahead.
Okay, so this is the material which we are using, PHPS. This is a amorphous silicon oxide material. So this material we treat like the two-dimensional perovskite on the top, and when we treat with this material, and this material hydrolyzes and coordinates with the lead and making the surface passivation very efficient. So you can see from here the cross-sectional images of this perovskite, that's a passivated perovskite. So the crystal structures are very nice of this perovskite. We passivated and deposited the whole transporting material. Can you see this slide where we are having the luminescence properties and transient?
Now we see the cross section, the scanning electron micrograph.
Okay, and followed by this one.
We stayed in the scanning micrograph.
Okay. I'm sorry for this inconvenience. I think we have still problem.
Yes, I think we are by scanning electron micrograph.
Okay. Do you see any slide movement?
I think maybe you need to use different way to. Yes, now we see the IV. Now it move again to another one.
Yes, now. Can you see?
We don't see anything. No. So I think we lost the presentation.
Yeah, I'm trying to revise this one. So no. Share. Can you see anything now?
Now it's download. Oh, no, it's again. Maybe you have to download again. Maybe
I have to reconnect it.
Okay, now we see the cross section of the scanning electron micrograph.
And next,
it doesn't work. Maybe you have just to do it very, very smoothly. Maybe when you.
I'm sorry, Zakhuddin, how many slides do you have?
Okay.
How many slides do you have? Because if it's too large, maybe you have to divide your file into files and start with one, and once finished, you go to another one. Is it really heavy, your file?
Yes, it's heavy. So what we do is, let me just summarize otherwise.
Good, thank you.
Yeah, thank you. So can we see?
No, I think we don't see anything now.
Okay.
It looked like if we lost the presentation.
Yes. Okay. Let me summarize. So since it's already 30 minutes, so I don't want to hold all this audience there. So we have a potential to create a new opportunities in these materials, and there are several investors who are approaching us, and we hope to create a startup and produce the pilot scale production of these perovskite modules with the 24% certified. And we are very happy to show that this technology with our new materials, which we are incorporating, that stabilizes and gives high efficiency, and this is our strength. So with this statement, I would like to thank all the audience and the organizing committee for listening to me, and I'm very sorry for this inconvenience in my presentation, which I was not able to share properly. Thank you all.
Okay, thank you, Professor Nasruddin.
Yeah.
Anyway, we will have now a discussion.
Yes.
I believe that as far as I know, the system, there are attendees who they look to us via YouTube and Facebook.
Yeah.
And I believe, as far as I understand, they cannot interact with us because they are not in Google Meet system. However, all the others who attend the conference via Google Meet, they can ask, they can discuss.
Okay.
The other attendee, that I regret too much that they cannot interact, they can write their request in Facebook, and I think we will manage to bring the answer from the keynote speakers and to send it to them, etc. So now I open the discussion inside the Google Meet. For people they are attending the conference via Google Meet to discuss this topic, and of course the other are also participating. So please go ahead and ask, and we have two keynote speakers, but I think very much the two topics are extremely important: the hydrogen from one side and the perovskite from the other side. And I think anyone who has a question, he can open his micro and ask. I will close mine.
Thanks. I will go ahead, Ahmed, and ask a question. Okay. Okay.
Yes.
Yeah. Thank you, Nasruddin, for trying very hard to finish your talk. I fully understand, and I want to extend my warm thanking for giving a talk today. We scheduled to have you last year in Agadir, and the last minute you couldn't make it. So we appreciate that you are here today. So as they say in Morocco or everywhere, the third one will be the best. So we extend our invitation to you as we speak now to see you in Wajda next year. So we're there. We will not have any glitches for sure.
Thank you. Thank you.
As we speak. So perovskite is a very hot topic, and you may know there is one of the problems for this to be deployed, which is their stability in water. How did you manage? Actually, you said you have already investors talking about this. How did you manage to make those materials stable in water in a way? If you can elaborate on that, that would be appreciated.
Yeah. So yeah, actually, this is the pity. Well, the first five slides, it was my introduction just to show high efficiency and the mini module capabilities what we are having. So the next slides was the material development, which we have developed, which we have a patent. So the one of the beauty of our configuration is we are incorporating fluorinated ionic liquids inside the perovskite bulk. So what this fluorinated ionic liquid is doing is it's a self-assembling a shell on the top of the perovskite grains. And this you can find out by doing the XPS analysis of fluoride only up to 25 nanometers, between 15 to 25 nanometers, this shell is there. And the rest is the remaining perovskite.
So you are saying that you make your material kind of hydrophobic surface, then it's not been attacked by water?
That's correct. So this hydrophobic material is ionic liquid, ionic liquid, this is hydrophobic ionic liquid, which is forming a shell. And second disadvantage of the perovskite is the ion migration because of the cation. So now since we are doping with the different ions of methyl ammonium, that's a imidazolium, and halides, and this compensates. So we are doing two things in a one shot.
And you don't lose any efficiency at all. It stays the same.
No, the highest efficiency, which I showed 24%, is based on without ionic liquids. The moment you bring this ionic liquids inside, you lose efficiency to 22. So
it's still very good.
It's still very good, 22%. So you don't reach 24%, but 22 you can reach.
And you have this already as a prototype. It's already working as a large scale.
Yes. Prototype which I showed you in the beginning. That is the prototype.
Thank you, Nasruddin. Thank you. And I'll take this opportunity to congratulate you live. The list of highly cited just came out half an hour ago. Congratulations on being on the highly cited. Always a pleasure to have you there.
Thank you. Thank you. I thought of discussing this information, but already we lost so much time. I didn't. Yeah, because I
are in the list. Congratulations. I have one question for BADR as well. Just so then I will let the other speakers take the opportunity. You talked about the hydrogen. Can you give us an idea from your own perspective about what's called the blue hydrogen and the green hydrogen, and which one do you actually think has more potential in the kingdom?
Yeah, it's clear for us. It would be, and it has to be, green hydrogen. It would be not a gray. It would be then clearly we're pushing then for green hydrogen. But of course, when we, as I said before, regarding the circular economy, when we will start as well then to capture carbon and then to produce synthetic fuels, we would like then to develop as well this opportunity to have a kind of real circular economy. But now the focus is more how do we have to produce 24 hours a day, very cheap electricity, or then with a very competitive cost of the electricity, to try then to see how is now the impacts for the different processes. If we're speaking about then electrolyzers, for some specific technologies, how is the impact on the of the intermittency? How is it, for example, for the follow processes when we speak about Haber-Bosch? This is then more difficult to have an intermittency, and this is why the idea now is really then to start to try to have this mix regarding then the very low cost of the electricity, and then to start producing then the green hydrogen. When we see now the opportunities in Europe, and then slowly the objective of the new Green Deal, the idea is to have more and more decarbonized products. And this is very important for us then to try then to start and then to highlight this possibility to have, as I said before, we hope then to have 100% then green hydrogen.
That's a very optimistic to see the least. I think it's a tough challenge, as you know, worldwide, and green hydrogen is the way to go. So let's assume you make it with electrolysis, then you get your energy from solar, which is green.
Yeah, as I said then during my presentation, wind energy might play maybe then more an important role, or it's maybe then more important as solar energy in this case because of the load factor. And there are some sites with a load factor up to 70%, and this might be then a good mix. And then later on, we have then to try to have then a system in which we have a buffer, and this is why then we have to develop and then to work on pilot projects to be able then to save the energy. But Si Mohammed Daoudi, I have as well a question.
Yes,
I would like then, I will take as well the opportunity then to ask you something. We know till now there are opportunities regarding the conventional storage of hydrogen. What
Yes.
are the other opportunities to store hydrogen?
I want to ask you that question, which is critical. After you make hydrogen, how would you transport it, which is another deal?
Yeah, okay. No, but this is why I said at the beginning for us the transformation to ammonia and to capture nitrogen to produce ammonia, or later on to have the hydrogen to add carbon and to have methanol. This would be the first derivatives which would be then exported. For the mid and long term, this would be then hydrogen. But I believe you are working as well on the topic then to store hydrogen, and what are the possibilities then to store hydrogen? Not only then on the conventional way, because I know there are some works regarding the storage in a matrix. Is there any possibilities? Because all the time the challenge when we have the very high pressure, this is a problem.
Yeah, that's a universal problem for everyone, including many companies actually. So the more efficient way, as you said, is liquid ammonia. That's what everybody is doing today. And there is a deal that just signed between Japan and the Kingdom of Saudi Arabia for that. The good thing about all this is it's a very hot topic of research that takes all the attention. And as you may know, the G20 ministers have already endorsed what's called the circular carbon economy, which is having the carbon dioxide as not our enemy, but our friend. If you can close that cycle, and hydrogen is one of the components of that. If you can make hydrogen green and cheap, which is not today, then you can take CO2 from anywhere, then you add it to hydrogen, you have your fuel. So,
yeah, no, definitely. But I wanted as well then to highlight, we have then to collaborate as well regarding the storage of hydrogen. There are really then opportunities, and then as well then membranes, because if we have then to work on the side of some components of electrolyzers, as well as later on a fuel cell, there is really then opportunities, and I hope we will have the opportunity then to collaborate on this topic.
Absolutely, this is a very important topic worldwide. If you can make hydrogen and CO2, you solve the whole problem. I agree, fully agree. Thank you, Badr, and thank you, Nasruddin, for opening these presentations today. Thank you very much. Very well appreciated.
Okay. So, next questions, if there is anyone, please. If you are in the audience.
Hello.
Yes.
This is Duval from Spain.
Yes, go ahead. How are you?
Fine, thank you. Yeah, thank you. So,
¿Cómo estás? Muy bien.
Yeah. Bien, muchas gracias. Yeah. So I have a question, in fact, for both speakers. So we'll start with the first one. So, Badr, do you know, as director of the center, do you know if there is some research on perovskite in Morocco?
Yes, I know this. We are working on this topic, and we are very glad because we have one very active researcher coming from KAUST. She joined us a few months ago. And we have now a team. We have now a team working on perovskites, and we're very glad that we have now as well this strong woman power coming and then supporting this team. And we have activities on in the green energy part, but there are as well other professors and labs working on this topic. There is as well University Qadi Iyad in Marrakesh is working as well on this topic, and I think as well in Agadir, but we are really then trying between Marrakesh and Ben Guerir to strengthen the works on this topic.
I see, thank you. So yeah, this is now a question for Nasruddin. So about how are you? By the way,
thank you for your compliments. Yes, tell me.
So I'm going to ask you about the 2D, 3D, let's say composites, I will say, or something like that, to sell.
Yes.
So did you look, or maybe around you, did you look about energy transfer, let's say from the 2D to 3D? Is there any possibility, because I see the energy diagram, so there is a possibility to excite your 2D, as you said, of course, from the top, and then you can transfer holes or electrons, or even could be energy directly.
Yes, thank you very much for this very nice question. So in our case, what we are doing is layer by layer deposition. And our next topic is incorporate these two-dimensional perovskite inside the bulk, creating different layers, n equals to 1 to 5. So the high energy ones will transfer to the low energy ones like a funneling system. In fact, your question is right, that it is possible to create this type of material in the bulk, having different energy levels. Finally, they funnel to the lowest energy one. It's possible, but we are doing that one. But the efficiency at this stage, because of the uncontrollable situation, is in the range of 17 to 18%.
I see. Anyway, if you want to look for some ultra-fast Hall and electron migration, you can just ask us. We can do that with terahertz spectroscopy and so on. Yeah.
Excellent.
And I have now another question about ionic liquid to protect, let's say, the perovskite. Ionic liquid because you have cation anions, and of course, perovskite also the cation anions.
Yes.
So there is the issue of let's say mutual interaction between the cation of one and the anion of the other one, and so on. Even you can have cation interaction, anion interaction, and this means that you might have migration from the let's say the cesium or potassium, whatever you're using, to the other side. So did you look at this issue? How is it relevant to the efficiency and so on?
So what we are doing is, we are not using just pure ionic liquid. Since we are chemists, we are functionalizing this ionic liquid with a long alkyne chain with fluorinated substituents. So in other words, like a Teflon, you create a ionic liquid Teflon. And by putting this Teflon type of material, from the perovskite, when you deposit from DMSO and DMF, which is a polar solvent, this ionic liquid floats on the top and self-assembling on top of the perovskite grains a shell. And this is the beauty of this materials. So it's a design concept of the ionic liquid which we have developed. It's not a normal ionic liquid which you buy from the commercial source.
I see.
We have substituted with a long alkyl chain, substituted with the fluoride groups.
Yeah.
Very special ionic liquid.
Thank you so much. Thank you.
Welcome.
So
thank you.
Any other questions? Doctor, I see two of them. So
okay.
One of you, anyone?
Please go ahead.
Okay. Bonsoir. Salam alaikum. Tadeusz Szumiata from Poland.
Your name, please?
Szumiata. Tadeusz Szumiata from Poland.
Okay. I remember you.
Okay. Thank you very much for giving me the voice. I have a question to Professor Naziruddin. When I was first of all, I would like to express my admiration due to the progress of perovskites, organic perovskites, in the context of photocells. But as I remember, when I was a student, it was very many years ago. We was taught that very prospective material is amorphous silicon or polycrystalline silicon deposited on foils using some organic chemical vapor deposition or something like that. What is the state of art of this technology, or maybe it is just stopped? Okay, thank you.
Yeah, thank you for this question. So amorphous silicon, the efficiencies are always below 12%. And this research has never progressed significantly. And then followed by the multicrystalline silicon solar cells, which is based in Neuchâtel, CSEM. And they tried their best to create these multicrystalline silicon solar cells, which the efficiency is never matching to the single crystalline silicon solar cells. But in between, when they started this amorphous silicon and multicrystalline silicon solar cells, single crystalline silicon solar cells cost was so expensive. Now that has changed completely. Now the single crystalline silicon solar cells are so cheap, and it's for IRESEN. So the remaining two technologies, multicrystalline and amorphous silicon, they are almost abundant. Similarly, Dyson solar cells also.
Thank you for this answer, Mr. Professor.
Okay, Dr. IKKEN.
Thank you, Ahmed. I have as well a question to Professor Nasruddin. Thank you very much for your very interesting presentation. And it was, even if we had some technical problems, but this is the risk with virtual events, but it was very interesting. I would like to ask you, even if it's maybe then not easy question. Now, maybe the question is easy, but the answer would be then maybe then a bit difficult. When do you expect that commercial modules, perovskites and PV modules will move from the lab to the fab?
So let me just can you see me?
Yes.
Yes.
I just want to show my expressions. As we are talking, tomorrow 11 o'clock, I have a meeting with the Sharjah Oil Company, National Oil Corporation. And tomorrow at evening, 5 o'clock, we have an Italian government which is very much interested. So we have a lineup of the investors who wants to come to EPFL and take our patents and invest on these technologies. And in 1 or 2 days, you will see the press release coming from EPFL that EPFL itself is putting a lot of money on this technology to get the lab scale to the pilot production. That's what we are doing first. And at the same time, we are attracting this funding to go to the production line. So we are jumping in 3 steps at a time, same time. We are doing the research, going to the pilot production with the help of EPFL money, and with the investors' money, we are going to the production line.
And do you expect maybe then in 3-4 years we might have then the first commercial products?
2025, we expect the product will be in commercial scale.
Okay. Thank you very much.
Okay. Next questions. Is there anyone? So if I have some questions for both of you. First for Nasruddin.
Yeah.
There are 2 ways now actually in perovskite when we go to industry. There is the perovskite for solar cell, and there is perovskite for light emitting diode.
Yes.
And I think both markets are very important.
That's true.
Now, which one will be faster than the other in terms of to go to start up and then to large scale? In your opinion, that's one question.
Yeah.
The second one, there are also 2 ways of making tandem solar cell.
Yeah.
There is one with silicon.
Yeah.
Align silicon in tandem with the perovskite, which can go to above the limit, the theoretical limit.
Yes.
Interesting. And there is also the one in tandem with CIGS, with copper-indium gallium sulfide selenide, which is interesting because it can be monolithically integrated.
Yes.
Which is very important maybe for encapsulation and stability.
Yeah.
I mean, the stability in terms of contact with the oxygen or humidity, etc.
Yeah.
In your opinion, which one of these 2 technology, monolithic integration, CIGS, or silicon will be the one will be also to go to the market? That's the 2.
Yeah. So let me, well, thank you for this highlighting this question. So let me start with the tandem perovskite silicon solar cells. Since the efforts from China to Korea to Japan and to European countries, the perovskite depositing on the silicon is a very dominant factor because of to break this Schottky-Quasi limit of 33% efficiency. That's the reason why including DOE is putting a lot of money to go for the tandem configuration. Okay, but being a scientist, what I would consider is going for tandem. When if you look at the recent paper coming from KAUST, particularly Stephen, he has published the difference in the power output depending on the temperature. So you have a mismatch between the perovskite output at the as the temperature rises and the silicon solar cell output. So this mismatch eventually is dragging the efficiency lower. In other words, the tandem solar cells is excellent concept, but integrating them into a single device and maintaining their efficiencies without bringing down the efficiency because of the problems of the mismatch, this can be a big problem. But otherwise, the tandem high efficiency are excellent idea. Having said that, if you look at the efficiencies, 25.5% efficiency, what we need is the stability. If we have a stability with this efficiency, you can penetrate into the market. Silicon solar cells, today we have only 18 to 20% efficiency. And people are, you can buy for the 2 cents per kilowatt hour. If the perovskite with such a cheap technology, we can even go below 2 cents kilowatt hour. Then you can start for green hydrogen economy even single junction solar cell with a 25% efficiency. This is my point of view, but there are other companies who are intensively spending their money on the perovskite technology, silicon perovskite tandem technology. Coming back to the CIGS, and the efficiency limits are below the silicon perovskite tandem cells, so the importance of the CIGS is decreasing.
Professor Nasruddin, if you allow me, what do you think about gallium arsenide? Because there are now then some companies working on gallium arsenide and PV cells in Korea and in China, and they reach already then 35% efficiency.
Gallium arsenide is a very excellent technology. It's very stable, but the cost of this technology is very expensive. Until unless if there is some technique where the gallium arsenide they can grow a cheap way, and then this is unbeatable.
Okay, so I will continue with you, Badr IKKEN. I think normally the strategy of IRESEN and the strategy of the Minister of Industry also in Morocco is to go to the industrialization.
Yes.
And to push the university to have this culture of startup and to go further. And instead of having just to have some people making their PhD and recycling to be professor at the university and so on, we want that people go to the business. Because that's what normally make other country in United States, in Japan, in Korea doing good.
Yes. Yeah.
So now, how we can do this in Morocco when we talk about hydrogen? Because in hydrogen, there is the bottom up, which is just to do some engineering with the electrolyzer, with the solar panels, and things like this, and to make some to produce hydrogen, etc., and to do some kind of innovation in this area of engineering.
Yes.
And the other one is top down, where we have to do fundamental research at the university to resolve problem of materials, to find the new material for the future as for catalysis. Which one will be founded in the future by IRESEN and by other institution in Morocco?
Yeah, if I were the director of this ENNAOUI,
the question is addressed to Badr IKKEN, but I will be happy to hear from you both.
Okay, let me just express my opinion, and then you Badr IKKEN can say his thoughts. So to me today, for the electrolysis, we are using platinum group metals. Certainly, the fundamental research to replace platinum group metals by 3D metals is important. In other words, develop new catalysts based on earth-abundant materials. This is the fundamental research which has to be encouraged, because existing materials, they are working and it's perfect material, but the cost-wise, it's not feasible to go with the platinum group metals. So the fundamental research to develop a new catalyst based on earth-abundant materials is important. That's my point of view.
Yeah, thank you very much. Definitely, I agree as well. I think there is a huge potential regarding composite materials as well to be able to decrease as well the costs. But if I have now to speak about all the parts of the value chain, and maybe then to go one step then before, maybe then on the macro level, before then moving on the meso and then micro. But macro, I have to say that we can't say, and of course you know this then well, and this is all the time a challenge for Morocco because of the limited funding, but we can't really then say it will work on this innovation, R&D and innovation ecosystem if I have only a part of the value chain, if I have only then applied R&D. I have to have all the different parts of the value chain. I think it's important. We are now in Morocco in a phases in which we will have a new specific law for research and innovation.
Okay.
I hope we will have then more funding for the different then steps. I mean, it's clear if I have to support universities, it's important to fund, to have scholarships for the PhD students, to have the adapted equipment, to have enough funding, and I think this would be then important. And the ministry in charge of research and higher education has to focus more on this part. Regarding the second part, regarding the valorization through applied research, innovation, products, and so on, we need as well, and we are trying then to push to have more instruments. Today in Morocco, even if it was the case 20 years ago, it was then possible to have a kind of research, le crédit impôt recherche, to have a kind of an adapted taxation model to be able then to fund then the R&D and then to pay then less taxes and to have later on then to reimburse then your tax. This is very important, and we normally next year we will have it. I hope we will have then more possibilities then to fund. If we have to see, and we have it now, we had it in the last months because of the pandemic COVID-19, we saw more the goodwill and the will to have more national preference, to have as well then more national products. And I said before, the idea is not to change all the globalization model, but we have to try all the time to guarantee the supply chain. If when I have then a problem everywhere and I know I would be not able to receive important components in different sectors because all the components are coming only from a parts of the world. This is important to change this model. I think that now we have then a lot of decision makers who are really sensitized regarding then this problem. I hope we will have then both sides of funding. What especially for IRESEN, I think we will try to have more funding for applied R&D and to push more for innovation. The ministry and then other partners, we saw, for example, in Morocco this year, we had two call for proposals supported by the University Mohammed VI Polytechnic, through, of course, then OCP, funding for different sectors, 17 million euros. And again, we will have then a new one. But I think the challenge in Morocco is to have more funding for technology transfer. We have very good researchers, we have very good activities on one side, but we need more to support the technology transfer.
Okay.
I'm sorry, it's a long answer because it's a very important topic, but a very complex one.
Okay. Yes, please. I saw the Canadian colleague. Oh, sorry.
Si Mohammed, micro.
We don't hear you. Maybe your micro is not on. Can you activate your micro in order to hear what's going on?
Maybe you have to unmute your micro.
We don't hear you.
I think he will try to connect again.
Okay, so let's is there any, can you now talk? No, we don't hear, unfortunately. So let's maybe you can manage to find out how it is. I just want to make one remark, if you allowed me. If we look to this unfortunate situation of COVID, and there is one couple in Germany from they are originally from Turkey, and they make a company called Bio, which is a very small company in the beginning, and they make fundamental work in virology and all this stuff, and now they are very well known, and they are even making an alliance with the big company in United States, Pfizer. Yes. So just this example to show that it's not like research is not like a jungle. The big fish eat the small one. It's not like this. So the big fish can work with the small fish and make it bigger. And therefore, I think we have to think about this in Morocco, that even if we don't have enough possibility, we can do a lot of things. So,
but Ahmed, I totally agree with you, and we have as well to be able to have this mindset that researchers are as well able to be entrepreneurs. But this is the point. Until now in Morocco, this is not really then the case. Sometimes you will have then some prejudices, because when you see one professor who is as well an entrepreneur, and this is important, because if we would like to create a new added value, we have as well to really valorize the work. And I think there are a lot of other instruments which we have regarding the mindset and the framework which we have then to change. But I totally agree with you.
So is it you have your microphone now, please? No, it doesn't work. I'm sure it's in your computer. You have to make the
maybe no. Professor, no, maybe you have to activate his microphone. Maybe from your side, it's
from me.
Maybe sometimes, yeah, because using other platform, I know that you can do it. You can deactivate it. You can activate.
Okay,
I don't know about Google Meet. Really, I have no idea.
Say, Mohammed, don't use those. Just unplug them and use the microphone and use the thing. Yeah. And try to use the thing regularly.
This is strange. The micro is unmuted, but there is no reaction. We don't see any signal.
Yeah.
Unfortunately, I cannot help. So is okay. Or maybe you can write down your questions, and then I can just talk about it. It's possible to write something.
And then maybe I think we have then to meet virtually again with Si Mohammed, and we have then to exchange.
Okay. So is there any questions from the virtual attendees? Any questions?
Well, if you don't have any question, I want to ask one short question.
Yes.
So Badr, I mean, the center which you have, does it have any strong collaboration with European Union, within what we say before ASH 2020, I mean, next program?
Yeah, of course. We had, when we started, 4 FP7 funded projects. We have as well a lot of H2020 funded projects as well. And we are now, of course, then in the phases to submit to the call of the new Green Deal Africa.
I'm saying this because I was looking all the time at collaboration for Morocco, something about, let's say, perovskite and quantum dot. Nasser knows that very, very well. It's hot topics. So I don't know, in Morocco, is there any lab or group really trying to this kind of materials? Quantum dot,
no. Yeah, especially I have then to tell you that regarding then perovskites, we don't have any H2020 project. We have then a lot of projects in the field of thermal solar energy, concentrated solar power, as well as thermal storage, but not then for perovskites. I have as well then to tell you, of course, this is, we can't really then generalize, but we had sometimes the feeling that when we were then in consortia, it was then more difficult than to have funding in the topic of PV. We were more successful regarding thermal solar energy. I hope this might then change. But today, regarding the perovskites, we have then 2 funded projects. One is own funding, one is funding then on the national level, CNRST, but we don't have the H2020 funded projects.
Okay, later I'll write you and let's see if we can do something together, yeah?
Yes, please. Marhaba. Thank you very much.
No, it's fine. Thank you. I'm sorry, yeah, sorry, that's fine. Thank you.
So is there any other questions, please? Go ahead. So one question from my side, the ammoniac. I think when we talk about hydrogen, automatically we have to talk about ammoniac. And Morocco, I think OCP in Morocco, the big company, they are very much concerned about ammoniac because they need to use ammoniac. Is there any big project regarding hydrogen and ammoniac in Morocco, actually?
Yeah, as I told you, AHMED, the R&D platform would be co-developed with OCP. The idea is to try to test the different possibilities, to test as well, as I said before, the buffer and the storage and all the different annex topics which are then important. And there is in the pipe project, and this is maybe now in the conception phases, to develop one project to produce then green ammonia on the commercial size and level, but the idea was really then to start with the R&D platform, and this R&D platform with the electrolyzers with the size of 2 megawatts would be installed in the industrial park and industrial site of OCP in Jorf. It means we will be then able really to have a first step to prepare an ambitious industrial and commercial project.
Okay. Sorry to be very curious again about the EV car and the fuel car or hydrogen car. I know that Schneider, you are making some project with Schneider to make some installation somewhere in Morocco. I want to ask you, what about this project? And the second, what about the hydrogen car? Is there any other company which are interested in this?
Yeah, thank you very much for the questions. The projects which you mentioned with the French company was one of the first projects to test, to have a kind of demonstration network and to have on the highway charging stations. We did it. As our colleague from Canada said, he said since a few months he was in the university all the time, and maybe he was as well very efficient. We had a lot of activities, and we developed, it was for us similar, and now we have done another project in which we developed our own charger. And we tried really then to go on and then to go from all the different technology readiness levels. And before the end of this year, we will start with the production of our own charging stations, different capacities. We tried as well then to have different innovations. We didn't reinvent the wheel. We tried to develop a product which might be then adapted to our need, which is adapted as well to our, I would say sometimes in some regions, some cities, our poor electrical grid, which is then adapted. And this was the target. And this is, and the result is a very good one. We're very then proud of this product. I will send you then the, because we finished the product, and we will communicate maybe then next week about this very interesting projects. I think in Morocco there is as well another project, but this is more a commercial one, which kind of a consortia of companies are working to develop one Moroccan electrical car. There is something in the pipe, and maybe in the next few months we will have more information about this topic. Regarding then hydrogen cars, we will have a small charging station in Ben Guerir, a small one, and we are trying then to have later on then a bigger one. When I say then a small one with low capacity would be then able to charge, for example, then 2 cars per day. This is only then for some tests, and then we will work on this topic, and then we hope to have then a real one in the near future. But frankly spoken, I have then to tell you that we have now some companies in Morocco which are strongly interested not on hydrogen and the hydrogen mobility, but they're strongly interested on synthetic fuels for the mobility. They have more interest to try to develop solutions for regarding then synthetic diesel, or maybe then synthetic kerosene, more as for the hydrogen mobility.
So from the biomass, you mean, or something else?
No. The idea is really then to produce green hydrogen, to cut carbon, to take carbon from concrete company, steel company, or something, and then to produce then directly a synthetic diesel through different then processes, and then to be able then to use it or to export it. At the beginning to export it, and then later on then to use it on the for the domestic need. I have as well to say that before the pandemic COVID-19, we had some European companies, and especially some companies which are then dealing with the carbon taxes. And they wanted as well to develop pilot projects regarding synthetic kerosene. Today, companies are more interested in synthetic fuels, more as than for green hydrogen for the mobility. And this is why you will see in our national strategy, it will start maybe then later on with the hydrogen mobility, as in Europe.
Okay. So again, I go back to the attendees. Is there any questions or any request? Otherwise, I will give the floor to the organization, to the organizer. They are in front of me. So Hamoud, please.
Thanks, Professor ENNAOUI. Thanks a lot for this moderation, and we want to thank Professor IKKEN and Professor Nasreddin, and our colleagues, Professor Daoudi and Professor Siaj, And we thanks a lot also the organizer committee, Professor Hamouti, Professor Jeffali, Professor Bouklah, PhD student Sifi, and many thanks for our president, Zagloul, and the dean of the faculty. And thanks a lot.
Okay. Just I want to remember that it's a 10 days conference. It's very important for the attendee to stay with us for 10 days. Every day is just a little bit. And I think at the end of the 10 days, you will learn quite a lot. Also, there is another thing. There are conferences related to the hydrogen or to the perovskite from Germany. Don't miss this kind of conference. There is one from one very, very expert in artificial photosynthesis. He is the one who bring the world record on hydrogen production with photoelectrolysis, and I think he will give a talk. He's from with 3,5 compound. It's very important. Then there is another talk about tandem solar cell with CIGS and perovskite from Helmut Center Berlin. Will be also. It's all are in the programs, and we will also advertise everything again on social media. So thank you very much. And if you have any last word, please go ahead. Otherwise, we will consider the session closed from my side. And I want to thank again BADR IKKEN. I want to thank the Nasruddin. I want to thank the all organizers from KOS, from Morocco, from everywhere. I think the conference is extremely amazing. And I think we have manpower, we have everything, we have just work.
I just want to join what Ahmed said. Thank BADR and Nasruddin for opening. Very well done, and thanks for the audience. And let us keep the momentum going for the next days, and only great things can come out of this. Thank you very much, and see you again tomorrow, inshallah.
Thank you very much. Thank you.
All the best. Thank you.
Thank you.